Welcome, my friends. In this video, I will be introducing a number of different trigonometric identities. A trigonometric identity is just a known equality related to a trigonometric function. Trigonometric identities can help us simplify expressions related to trigonometric functions. Many of these identities you are most likely already familiar with, such as the reciprocal identities. You're most likely already familiar with the reciprocal trig functions. Cosecant of x is equal to 1 over sine of x. This is a trigonometric identity, meaning any time that we have cosecant in a problem, we can freely convert that to 1 over sine, or vice versa. We also have secant of x, which is the same thing as 1 over cosine. Cotangent is the same thing as 1 over tangent. Most commonly, this is the direction that we'll use the reciprocal functions. If you see cosecant, secant, or cotangent, it's very common to convert those into either 1 over sine, 1 over cosine, or 1 over tangent. This can oftentimes simplify your problem. We can also go the other way around. So sine of x is the same thing as 1 over cosecant of x, cosine of x is the same thing as 1 over secant of x, and tangent of x is the same thing as 1 over cotangent of x. We also have the quotient identities, which are related to cotangent and tangent. Tangent can be expressed as sine over cosine, and cotangent can be expressed as cosine over sine. Altogether, these are the 6 reciprocal identities and the 2 quotient identities. Let's practice using these identities to simplify trigonometric expressions. Let's say we are asked to simplify the expression sine of x times cosecant of x. We know by one of these 6 reciprocal identities that cosecant of x is the same thing as 1 over sine of x. So we could rewrite this problem as sine of x times 1 over sine of x, since cosecant of x is equal to 1 over sine of x. The signs will cancel, and we will be left with just 1. Sine of x times cosecant of x is the same thing as 1. Let's try another one. We are asked to simplify the expression cotangent of x times secant of x. Now, every trig function can always be converted into sines and cosines. That's a very good strategy if you're stuck on a simplification problem. Convert everything into sines and cosines, and typically something will cancel. In this example, cotangent is the same thing as cosine over sine by the quotient identity. By the reciprocal identity, secant is the same thing as 1 over cosine. So let's make these substitutions in our problem. We will have cosine over sine times 1 over cosine. The cosines will cancel, and we will have just 1 over sine. But of course, 1 over sine is the same thing as cosecant. So cotangent of x times secant of x is the same thing as cosecant of x. Let's try this one. We are asked to simplify the expression cosecant of x divided by secant of x. We know that cosecant of x is the same thing as 1 over sine of x, and secant of x is the same thing as 1 over cosine of x. We can reciprocate the denominator and multiply so that we have 1 over sine of x times cosine of x over 1. This is the same thing as cosine of x divided by sine of x. Of course, by the quotient identity, we know that cosine over sine is cotangent. So cosecant of x divided by secant of x is the same thing as cotangent of x. Now, there is an alternative way that you could solve this problem that's a little bit more efficient. Whenever you have trigonometric functions that contain fractions, you can always convert to the corresponding reciprocal function by moving to the opposite side of the fraction. For example, cosecant could be converted to sine in the denominator, and secant could be converted to cosine in the numerator. So we can go straight from this step right to cosine over sine, which of course is the same thing as cotangent. Let's try this one. We are asked to simplify the expression cosecant of x times cosine of x divided by cotangent of x. Just like I was mentioning in the previous problem, when you have a fraction related to trigonometric functions, you can convert to the corresponding reciprocal function on the opposite side of the fraction. Therefore, I'm going to change the cosecant to a sine in the denominator and cotangent to tangent in the numerator. This is what we have. Now I'm going to convert tangent to sine over cosine, so that we have sine over cosine times cosine over sine. The cosines will cancel and the sines will cancel, and we will be left with just 1. Cosecant of x times cosine of x divided by cotangent of x is the same thing as 1. Okay, there's one more type of identity that I want to introduce in this video, and that's what are called the even and odd identities for trigonometric functions. Before we introduce the even and odd identities, we have to talk about what is meant by an even or odd function. For an even function, if you plug in the negative or positive version of the same number, you will get the exact same output. For example, f of x is equal to x squared is an even function. If you plug in 3 into this function, you will get 3 squared, which is equal to 9. If you plug in the negative version of the same number, which is negative 3, you will get the exact same output, 9. Since if we plug in the negative or positive version of the same number into this function, we will get the exact same output, that means that f of x equals x squared is an even function. It turns out that cosine is also an even function, so if I plug in the positive or negative version of a number, I will get the exact same output for cosine. Think for a moment in your head about the unit circle. Cosine is the x-coordinate on the unit circle. At pi over 2, the x-coordinate is 0. So that means that cosine of pi over 2 is equal to 0. At negative pi over 2, that would mean that we are traveling clockwise on the unit circle. At negative pi over 2, we would still be at an x-coordinate of 0, so cosine of negative pi over 2 would also be 0. This works in general for any argument that we could plug into cosine. Cosine of a positive angle will be exactly the same as cosine of the negative version of that angle. In general, we write this as cosine of negative x is equal to cosine. In practice, this means that if you ever have cosine of some negative angle, you can literally just drop the negative sign. It won't make any difference in terms of your final answer. Now, since secant is the reciprocal of cosine, this also applies to secant. So secant of negative x is the same thing as secant of x. Together, these are the two even trigonometric identities. Cosine and secant are the only two even trigonometric functions. All of the other trigonometric functions are odd, so let's talk about what that means. For an odd function, if you plug in the negative version of a number, you will get out the opposite output with a changed sign as if you plugged in the positive version of that number. So I know that's a little bit wordy, so let's look at what we mean by that. For example, f of x is equal to sine of x is an odd function. That means if I plug in some argument, such as pi over 6, and get some output, such as 1/2, if I plug in the same angle but with an opposite sign, I should get the exact same answer but with a changed sign. So sine of pi over 6 is 1/2, and sine of negative pi over 6 is negative 1/2. In general, for a function to be odd, if you plug in the negative version of a number, you should get the exact same output as if you plug the positive version, except for the sign will be switched. The general way that we write this is sine of negative x is equal to negative sine of x. In practice, this means if you'd like to get rid of the negative sign on the inside of a sine function, you can simply change the sign of the entire function. Since cosecant is the reciprocal of sine, cosecant is also an odd function, so cosecant of negative x is equal to negative cosecant of x. It turns out that tangent and cotangent are also odd functions, so we have the exact same result over here. Altogether, these are the 4 odd trigonometric identities. We will practice using the odd and even identities in future videos. Alright my friends, that finishes this video introducing trigonometric identities.